Hi, everyone. So today we are going to look at the application of boundary conditions in electrostatics. So here what the question is asking us is that it says this is medium 1, this is medium 2, and here in medium 1 we have epsilon 1, which is epsilon r1 epsilon naught, and then we have epsilon 2, which is epsilon r2 epsilon naught. So here what is asked of us is that electric field in medium 1 is given in the general form of Ex x hat plus Ey y hat plus Ez z hat. This is the electric field in medium 1. So let's call these all 1 here. Now it asks us, if that is the case, and you know epsilon 1, you know epsilon 2, find the electric field in medium 2 here. They were actually written here. So this is epsilon 1, epsilon naught. This is epsilon naught, r2, epsilon naught. And then also what is asked of us is that what is theta 1 and then theta 2 here? Basically the angle that the electric field exists and is directed in this medium. Okay, so these are all going to be parametric, so you don't have to drive any numbers for them. But as the name suggests, this is the application of boundary conditions. So first thing you should do is to write the boundary conditions in electrostatics. You know that E1T, the tangential component of the electric field, must be basically continuous. So E1T and E2T should be equal. Then n hat dot D2 minus D1 must be rho s here. Whenever I've repeated this, I think too many times, but whenever rho s is not given to you, you assume rho s is 0. In any medium, if it is not indicated yet you have some volumetric or surface or line charge density, then you assume it is 0. So here, since the question didn't give us any surface charge density in the boundary, we are going to assume rho s is going to be 0. So what do we end up with? We end up with E1T must be equal to E2T, and D2N must be equal to D1N, the normal component of the electric field here. Okay, so looking at the surface, which is lying in XY plane, this is our XY plane, this is our Z. What is the normal component of the surface? That's the first thing you should do. Find the normal component, n hat here. What is going to be n hat? N hat is exactly in Z hat direction. So if that's the case, if n hat is equal to Z hat, then the tangential component of the electric field on this boundary is going to be the X and Y component of the electric field. So E1T is going to be E1X, X hat, plus E1Y, Y hat, equal to E2X, X hat, plus E2Y, Y hat. So now you have two vectors that must be equal, and that means that the component in X hat direction and the component in Y hat direction must be equal exactly. E1X must be equal to E2X, E2Y, E1Y must be equal to E2Y. Now, for translating the normal component of D, the normal component of D is actually going to be D2Z in Z hat direction, E1z, because the normal component of D is basically D2 dot Z hat here. So let me write it. This means D dot N hat. And since we have D dot Z hat, basically that means DZ. So I'm going to quickly write it here. Okay. So D2Z must be equal to D1Z. Inside the dielectric, we know D is equal to epsilon 2, epsilon multiplied by E, which means epsilon multiplied by E2Z must be equal to epsilon 1 equal to E1Z. Okay, so we found E2Z must be epsilon 1 over epsilon 2 E1Z. Great, we found E2 basically. E2 must be exactly as E1x, x hat, plus E2x, E2, sorry. Let me start from the beginning here. E2 is basically E2x, x hat, plus E2y, y hat, plus E2z, z hat. That's the representation of a vector in Cartesian coordinate system. Now we found out that E2x is equal to E1x. So I'm going to put this as E1x. I found out E2y is equal to E1y. Okay. E2z is equal to epsilon 1 over epsilon 2 E1z. So if given the vector E1, we found vector E2 plus E1y, y hat, plus epsilon 1, epsilon 2, E1z, z hat. Great. So remember, these are known. In the question that is given to you, these are known. Okay. Now let's find out what is angle theta 1 and angle theta 2. Angle theta 1, if you look at it here, is exactly theta, tangent of theta 1 is going to be E1t, amplitude of E1t, over amplitude of E1z, right? What is the amplitude of E1t? It is amplitude of this vector, E1x, x hat, plus E2x, y hat. Sorry, E1y, y hat. This is the amplitude. And this is E1z. Great. So this is going to be, amplitude of a vector is going to be E1x squared plus E1y squared over E1z. That's the amplitude. So tan theta 1 is going to be tangent minus 1 of E1x squared plus E1y squared over E1z. So again, if E1x and E1y, E1z are given to you, you can find theta 1. Let's find theta 2. Tangent of theta 2 is going to be the same thing. Here, look at it. It's going to be amplitude of E2t over amplitude of E1, E2z. This over this. Now, E2t is exactly as amplitude of E1t. E2z is going to be epsilon 1 over epsilon 2 E1z. We just found out they define this as tangent of theta 1. So we can say tangent of theta 2 is tangent of theta 1 over epsilon 2, epsilon 1. So this is a very important conclusion, that the angle tangent theta 2 is epsilon 2 over epsilon 1 tangent of theta 1. So again, if you know E1x, E1y, E1z, you can calculate theta 1. If you know theta 1, and then you know the characteristic of your mediums, which are epsilon 2 and epsilon 1, again, these would be given to you. You can find tangent of theta 2. So that is how you would solve this problem. Thank you for watching this. Please make sure that you can do the same calculation here.